To create the example Vivado project, we need to start a shell in the work directory. The make file contains the command proj-gcu104 that will copy the files needed to set up the project, then call Vivado to build the project. If you are not on Linux or do not have access to the tools to execute makefile commands, the makefile serves as a documentation of how to build the Vivado project. To build the Vivado project, first it unzips the IMAGine IP into a subdirectory. Then it creates a directory where the Vivado project files will be created. Next, it copies the project creation tickle script into the project directory. Then it enters the project directory and calls Vivado from command line, sourcing the project creation tickle script. Note that for this command to work, Vivado needs to be visible to the shell environment. So let's go ahead and set up the shell first. Right now I do not have access to Vivado in my shell. I have set up the command vivado init, which configures my shell to use Vivado. Now I can call the make command to build the project. As we can see, it has unpacked the IP in this folder and then it started building the project using Vivado. As seen in the block diagram, it is a simple system where the IMAGine IP is connected to the Zinc processor through an AXI bus. By default, the IMAGine IP is configured to have a 64 by 64 array of processing elements. IMAGine uses Picasso as the PIM tile, where each block has one row of PEs with 16 columns. Thus, 64 by 4 PIM tiles gives us an array of 64 by 64 PEs. As you can see, the clock frequency of the programmable logic is configured to run at 300 MHz because of the clock frequency limitation of the AXI bus. The IMAGine IP can run as fast as 737 MHz on UltraScale Plus devices. However, that requires a dual clock design, which I am having trouble to set up. Thus, even though the IP has two clock ports, both of them are connected to the 300 MHz clock. The next thing to do is to run validation on the design. If no errors are found, we can start generating the bit stream. The bitstream generation process might take a while, so I'm going to pause the recording. Okay, so I started recording the video again, and as you can see, the bitstream generation was completed. It took around 20 minutes to compile it on my machine with 8 cores. As you can see, it passed the timing without any violations. In another video, I will show how to write a basic application for this platform using IMAGine to perform GenV operations.